Okay, hi and welcome to video notes 11.4 where we're going to talk about radical operations. Now we already did a little bit with radical operations. Really, we kind of talked about multiplying square roots in my last video. We'll review that again, but really what we're going to try to add in here is addition and subtraction. Here's the best place to circle it. And talk about what that means and what that looks like and what that operation is, because that one's going to be important. And then additionally, we're going to sneak into and talk a little bit about division in this one. We're just going to do a division kind of lightly with this and get some of the basic properties. So let's talk about this addition of square roots. With addition of square roots, what we're looking for here is a like square root. And just like variables, you can see here I have this little box that says treat rads like variables, at least under this portion in all intents and purposes for addition and subtraction. What that means is we need to have the same exact square root underneath. And then we're going to look at the coefficients and we can add or subtract them. But if we don't have the same variable underneath, say this was a square root of b, we couldn't combine them because they would not be like radicals, if you will, LR, just to shorten it up a bit there. So we don't want to do that. So that's really what we're going to look for is combining radicals have the same value underneath the radical sign and then adding the coefficients. So coefficients add, radical stays the same. There's a quick little summary of that. And with multiplication and division, the main thing that we're going to look at with doing with these, and we saw this before, is that under a radical, if there's two things multiplied, we can separate the radicals, and then vice versa, because this works both ways. If we have two things that are multiplied with radicals, they can be placed under the same radical and multiplied. And we'll use both versions of that. And kind of the same thing with division. So if we've got the radical of some division or ratio, we can split that up into two radicals or combine it again as well, whatever we need to get our work done. So let's take a look at an example here. I'm going to walk you through 1a here. So we've got the square root of 2 plus the square root of 3 plus the square root of 2. I broke this up a little bit longer in the show to show you all the different parts of what's happening here. All of these do have a coefficient of 1 because it's not written, so we know that that's 1. And so I went ahead and add that in there. Well, I shouldn't add it for the 3, but it's not so important there. What we want to do now is that we're going to recognize that the square root of 2 and the square root of 2 are going to be like radicals, have the same value underneath the square root sign there. So we're going to arrange them so that they're next to each other. And then this is what's going to happen is that the coefficients of those are going to add where that radical is going to stay the same. This is kind of like the reverse distributive property. And what we end up with is 2 square root of 2, again 1 plus 1, radical stays the same, plus the square root of 3, and you'll notice that I forgot the square root there, so square root of 3. Okay, so let's move on to the next example here, which is 1b. And you'll notice in 1b that these square roots are different from each other. We got a square root of 5 in two terms, and we've got a square root of 7 in two terms. Let's talk about something real quick here. We have to make sure that these square roots are in the simplest form. So make sure that you reduce first at all points and at all possible points here. For example, look at C here, where you got 5 and 20. Notice that there is something in there, a perfect square factor that we can take out of there. So make sure they're reduced first. But if they're reduced down as far as they can go, then you want to go ahead and start combining or multiplying. In this case, these are all under addition and subtraction there. So what we want to do is we want to take this 4 times the square root of 5 and this 2 times the square root of 5, and that they have the same like radicals. So we're going to move them next to each other using the commutative property of addition so that we can see them right next to each other. All right, now we're going to take this square root of 7, this 3 times the square root of 7, and this negative 1 times the square root of 7, and move them next to each other. And this is us just showing our work, showing that we're organizing ourselves, and we're able to see what we're going to combine. These two now are going to combine. Again, remember, coefficients add, radicals stay the same. So this is under addition, so it's going to be 4 plus 2, which is 6 square roots of 5. And these are going to add from 3 and a negative 1, so they're going to add to 2 square roots of 7. And since they're not the same radical, we're done. That's simplified all the way. Okay, so let's take a look at some multiplication here. There's two ways we can look at this one. The first thing that we can do is look at, well, hey, I think 20 here has a term that would help me get to a square. And remember, squares are the inverse of a radical. So if we want to get something outside of the radical, we need to find a square, or a number times a number. And 20 just so happens to be 5, oops, I'm sorry, there's the 5 originally. So 20 happens to be 5 times 4. And then what I've got here are these two 5s, which means I can square them. So I put them together and put 5 squared. And what that means is that this radical is going to reduce with that square, and this 5 is going to come outside of that radical. So this 5 is now free of the radical. And you'll notice that this 4 can be changed as well. I probably should have done it at the same time, but I'm going to go ahead and change it now. So now the 4 can be thought of as 2 squared. So I'm going to go ahead and reduce that out, and then that's going to be 5 times 2, or this is going to result in 10. Another way to look at this really quickly is to multiply those out. Sometimes it helps, and we'll notice that 5 times 20 is 100. And 100 just happens to be 10 squared. And again, looking at this, squares are the inverse of a square root. So if we want to get something out, we take and find a square. And we'll find that that's also 10 because they should be the same. Let's look at one more division one here. And so here's a division of square root of 25/16. So we're going to break this up into two different radicals. So I'm going to break the top into the square root of 25 over the square root of 16. Now that lets me work with them separately, which is kind of what I want to do here. And the top part, or the numerator, is going to turn into 5 squared. Again, it's a perfect square factor. And the bottom is also a perfect square factor. It's going to be 4 squared. In this case, again, squares and square roots undo each other, right? They're inverses of each other. So that leaves me just a 5 in the numerator and just a 4 in the denominator. All right. I will flip over to the next page and I'll see you there. Okay, here we are on the back side, and what I want to talk about first on the back side is signs with square roots. Signs meaning that first we have to identify this term called the principal square root. And the principal square root really says that we're only concerned, or I guess we always assume, that the positive value coming out of the square root is what we're looking at. That's what the principal square root means. It means we're really just looking at the positive value. I'm going to not go into detail of why that is, but we can look at negative square roots, but you'll clearly see the negative out front. If you happen to see a positive and a negative, that means that we're looking at both the positive and the negative of the square root, which again, we like to do sometimes. And this will make more sense as we move along. But for today, we're just going to kind of see what that looks like. So let's jump down here to an example. So here is the square root of 64. We assume that it's the principal square root, so we're going to look at the positive version of it. Again, those are canceling if you didn't catch that. Here's one that's negative. We already saw the square root of 100, so we know what that's going to be, right? Square root of 10 squared. Those cancel, so we get negative 10 as a result. But notice, very importantly, the negative is on the outside. Here's a plus or minus with a division of the square root of 9/16. So what would that look like? Well, let's go ahead and split this up. It's going to split up into the square root, well, let's just change it now, 3 squared, and the square root of 4 squared. Those are going to reduce out, leaving me with plus or minus 3 over 4. What does that really mean? Well, it means that I really have two solutions for this. I've got positive 3/4, and I also have a negative 3/4. So that's what this plus or minus means. We get two solutions. So anytime you see that, you have to account for two things that are coming from that square root. Obviously, plus or minus 0 is negligible because 0 is 0 there. Here's a couple other examples to look at, but this one right here I want to stop on before we move to the next topic, which is the square root, and notice the negative is clearly underneath the square root. We're not ready for this. This will be in a couple of days for us. We'll talk about what that means because that's kind of a special scenario. Okay, for the last bit here, we want to bring back some information that we've seen before, which is our number sets. Because we've talked about this, certain number sets can be derived from different operations. In this case, if we have a division, right, the division, or really multiplication, I guess, since they're inverses of each other, we end up what we call a rational number. It falls in the rational number set, meaning it's got decimals, can be a fraction, all that fun stuff. Irrational, on the other hand, we've learned, right, from a long time ago, comes from a square root sign. So anytime that we have one of these radicals that we're solving or square roots that we're solving that ends as an actual number, it's going to be considered irrational. If it ends with a square root as part of its solution, then we're going to call it irrational. Notice I haven't done any of those in my hand, but you can see there's some additional ones here. And notice, again, in these examples, just really quickly here, you'll see that all of these are exactly the same as the ones up top. So we have them all solved here. So let's go ahead and name these. This one being 8 is going to be considered a rational number. It really could be pretty fancy and say it's specific to whole numbers, but we're going to call it rational because that's included in there. Negative 10 would also be rational. 3/4 would be rational. 0 is rational. Now look at E, though. When we work down through this one, you can see that we get a plus or minus 2 square roots 11 and negative 2 square roots 11. Because there's a square root that we can't get rid of, we're going to call that irrational, meaning that that decimal that comes from there doesn't repeat or doesn't end. So any of these, this one is not a square root, and it is an ending decimal, so we would call that rational, where the square root of 5, again, would be irrational. And this one is a different number set, very special one that we're not ready to talk about yet. So in these notes, let's just quickly summarize. We talked about what rational and irrational means coming from square roots. We talked about the positive and negative, meaning that we get two versions of a square root or two solutions from a square root. We talked about the fact that we usually deal with the principal square root, meaning that we talk about the positive one mainly. And we covered two new operations, which is adding like square roots, meaning that they have to have the same value underneath the square root, and then we add up or subtract up their coefficients. And division, meaning that we can split a division of a ratio underneath the square root into two separate ones as we see fit. All right, thanks for watching the notes. We'll see you.